Confusing starships. The starships of the Solar Federation are marked with the symbol of the Federation, a circle, while starships of the Danubian Empire are marked with the empire's symbol, an ellipse, whose major axis is 1.4 times longer than the minor axis. A is equal to 1.4b. How fast, relative to an observer, does an empire ship have to travel for its marking to be confused with the marking of a federation ship? So how fast must the empire ship travel with respect to a stationary observer so that the ellipse will appear to be a circle? That's the question. Okay. So if S reference frame is our observer reference frame, and S prime reference frame is the empire reference frame, and the empire ship is moving with respect to the observer. Now, who is measuring the proper length? Because the marking on the empire ship is stationary with respect to an observer on the empire ship. That observer will be measuring the length properly. So empire reference frame is the proper reference frame. Why? Because the marking on the empire ship is at rest with respect to an observer in this reference frame. Okay. Now, let's say that the empire ship is moving on the y-axis with respect to the S reference frame with a constant speed v. So S prime moves on the y-axis with a velocity v with respect to the S reference frame, our observer, who is stationary. Now, these two reference frames, observers on these two reference frames, are reporting a length. And since this is the proper reference frame, and this is not the proper reference frame, we have length contraction. So a delta y measured in the direction of the motion, relative motion of the two reference frames, is contracted so that the length measured on the S prime reference frame, delta y prime, will be divided by the relativistic correction factor gamma. All right. So delta y will be delta y prime divided by gamma. Now, what is gamma? Gamma is the relativistic correction factor 1 over 1 minus the relative speed of the two reference frames squared divided by the speed of light squared inside the square root. And this phenomenon is known as length contraction. We have two important phenomena in special relativity: length contraction and time dilation. So this is the length contraction. So we have to find the proper reference frame, and the improper reference frame measures a length that is contracted with respect to an observer on the proper reference frame in the direction of the relative motion of these two reference frames. So now I have the delta y measured by the S reference frame, observer reference frame, should be equal to, instead of A, it should be equal to B, so that this is going to turn into a circle. So delta y should be equal to B, but what is the proper delta y? It's delta y prime, which is A, that is 1.4b. So it is 1.4b divided by the relativistic correction factor gamma. So I find that gamma square is equal to 1 over 1 minus v square over c square, and that is 1.4 square, which is 1.96. And why am I requiring delta y to be equal to b, the minor axis of the ellipse? This is because I want the ellipse to appear so that the ellipse appears to be a circle. The length contraction is only on the y-axis because the relative motion is on the y-axis. For the lengths measured on the x-axis, they will be measuring the same thing, that's b. But for the y-axis, one is measuring the proper length a, the other one will be measuring also b, length contracted. Okay, so with that I have 1.96 minus 1.96 v squared divided by c squared is equal to 1. So I obtain v squared divided by c squared is 0.96 divided by 1.96, and I take the square root of both sides, and this will give me v must be equal to 0.7 c. If I plug in for c 3 times 10 to 8 meters per second, 2.10 times 10 to 8 meters per second. Okay, that was the question. How fast relative to an observer does an Empire ship have to travel for its marking to be confused with the marking of a Federation ship? It must travel with 0.7 c on the y-axis. The enemy ship must be traveling on the y-axis with a speed 0.7 c with respect to a stationary observer. Okay, so we were told that the starships of the Solar Federation and the Danubian Empire have different markings. One is a circle, the other one is an ellipse, and the ellipse has its major axis 1.4 times its minor axis. So if we look at the Empire spaceship from a reference frame that measures the lengths to be contracted, when the Empire ship moves on the y-axis, this A will appear to be equal to B, and the ellipse will turn into a circle, so we can confuse it. We could get confused with the Federation ship. And how fast should it travel? Well, if you look at the Empire ship moving with relative speed v on the y-axis with respect to the S reference frame observer, the length measured for this marking on the y-axis in the Empire ship is correct. Because it's the proper frame, the marking is at rest in this reference frame. As for the S reference frame, we have length contraction. Delta y prime divided by gamma will be the length measured. And gamma is 1 over square root 1 minus v squared over c squared, the relativistic correction factor. And the delta y we should measure must be b instead of 1.4b, so that it appears to be a circle. And solving for v from this equation, gamma square is equal to 1.4 square, we can find that v is 0.7 c, 2.1 10 to 8 meters per second, moving on the y-axis.